You're welcome for this lesson. Today we are going to look at the derivatives of natural logarithmic functions, what we call ln x. Now, when we are writing this ln, we can as well put the magnitude, reason being that ln can never be a negative. So in some books, when you find them writing it like that, it's just to show you that we cannot have a negative ln. And what is the rule when we are dealing with ln? So we know very well that whenever I have a function, let me say y is equal to ln of x. Now, in case I want to differentiate this, I need to remember always that ln is the same thing like log exponential. Exponential is the base. So when I come back here, I can write this as y is equal to log x. But you know that from our rules of logarithms, you have to remember the rules of logarithms. That when I have log AB is equal to C, this is the same thing like having B is equal to AC. So when I apply the same knowledge here, when you look at it very well, what does it mean? It means that your A is the X is the same as B, and your Y is the C. So meaning that we can have this written as our B we have said is the X, so we can have it as X is equal to X power Y. Now, if we are to differentiate this with respect to Y, it means that we shall have dx is equal to EY dy. So if I'm interested in obtaining my dy dx, it means I will divide both sides by dy. I will divide both sides by dx. So here I can have dx out of my ey dx equaling to ey out of my ey dy out of dx. So what do I have? This side I remain with 1 out of ey equaling to dy dx. And therefore it means that our dy dx will equal to 1 out of e power y. But y, we know very well, we know that our y is the same as the natural log of x. So meaning that we can have dy dx is equal to 1 out of e natural log of x, because we know that y is equal to ln x. But whenever you have e natural log, this is the same as, you can even place your calculators, that whenever you have e natural log of anything, you still get that same thing. So e natural log of x is the same thing as x. So here we shall continue and say this is the same as 1 out of x. But that one comes from here. You know very well that when I have ln of e, this is the same as having log of EE, which is the same thing as 1, because the base and the base are the same. So here we can still write this as 1 out of ln EX. So ln E is the same as log EE, which is equal to 1. And therefore, it is from this point that I want to conclude that whenever, this is now our conclusion, whenever we have dx of ln of x, this is the same thing like having 1 out of x. So that one, you take it, you take note of it. So whenever we have it, that is what we end up with. So it is an important thing to take note of. So whenever you differentiate a natural log of x, you'll end up with 1 out of x. Okay, we can now look at another important derivative of the natural log. So here we are going to look at the derivative of natural log in terms when we have our function f of x. Still, we are going to come, we are going to, we are going to come of ln f of x. So when you find the magnitude just to show you that you cannot have a negative. So you can say that our y is equal to natural log f of x. What does it mean? It means that I have told you a chain rule is going to be an important rule. So we are going to say that let f of x equals to our u. So what does it mean? Then it means that our y will equal to ln of u. But we have already said that when I have the y, the u, this one will always be 1 out of u. Then our fx is equal to u. It means that when I differentiate f prime of x, I'll end up with the u dx. So what does it mean? It means that my dy dx will equal to my dy du then times our du dx. So this one will give us the y du. Here, my dy du is 1 out of u, then times du dx, which is f prime of x. So here I have my dy dx equaling to my f prime of x out of u. But what is u? Our u from here, u is equal to f of x. So meaning that my dy dx will equal to f prime of x out of f of x. And therefore here, we shall have our conclusion that whenever I have d dx of ln of f of x, this one will always be f prime of x out of f of x. And this one is going to be our general rule that whenever you meet a natural log, always you have to go on differentiate the function, then divide by the original function. Differentiate the function, divide by the original function. We can look at an example. And our first example is here. Differentiate with respect to x. And what do you have? We have number one, we have ln of 5x. But I'm going to show you both approaches. So we can first say let y equals to ln 5x. Now here, if we are to use the from principles, it means that we shall say that let our u equals to 5x. Now this is our function 5 of x. So meaning that your du dx will equal to 5, because you know that when you are differentiating, this is to power 1. So you say 5 times 1, reduce the power by 1, you say x power 0. So 5 times 1 is 5, x power 0. X power 0 is a 1, so you get 5 times 1, which is 5. Then it means that our y is equal to ln of u, because 5x is u. But we say that always, whenever you find the ln of u and differentiate it, you get the same thing. So the y du will always give us ln of, what will it give us? It will give us 1 out of u. So here, allow me to remove this. So here, we shall have 1 out of u. So we go back and say now, our dy dx will equal to dy du, then times the du dx. So your dy du we have obtained is 1 out of u, then times du dx, which is equal to 5. But what is our u? Our u is 5x. So we shall have 5 out of the 5x. Hope out of the 5x. So when you try to reduce, this 5 and the 5 will cancel, so you remain with 1 out of x. And this is our dy dx. Alternatively, like we have said that whenever you meet these functions, dx of any ln of any function of x always is given by f prime of x divided by the original function. So here our f of x is given by 5x. So meaning that f prime of x will equal to 5. So meaning that dx of ln of 5x is going to be f prime, which is 5, divide by original 5 function, which is 5x, by 5 by 5, 1. So this 5, 1, 5, 1. So you remain with 1 out of x. So that is the other approach that you can use. So once you use that approach, you still end up with the same answer. So that is the second approach that you can apply. And also it will lead you to the same answer. Okay. Okay, so we are going to try out another number. We are going to try out another number. Okay, so I can share my... Okay, we try out another number. So another number we are going to try out is going to be differentiate still with respect to x. And what do we have as our function? We have ln. We have our function as ln of 5x minus 4. Still, we shall say that let our y equals to 5x minus 4. Let our function be equal to 5x minus 4. Then you are going to select your u equals to 5x minus 4. That is our function. So meaning that your du dx will equal to 5. Then what does it mean? It means our y is equal to ln of u. So your dy du here is equal to 1 out of u. Whenever you find ln u, ln x, ln what, always just say 1 out of that same thing. Then when it comes now, we apply our chain rule. dy dx will equal to dy du, then times our du dx. So what is our dy du? Our dy du is 1 out of u. Then what is du dx? Du dx is 5. So this one will give us 5 out of u, which is the same as 5x minus 4. So this one is going to be our dy dx. So you end at that point. In case you want, you can apply the other alternative. The other alternative approach tells us that when I have ddx of ln of f of x, this one is always equal to f prime of x divided by f of x. So for you identify, what do we have? We have ln 5x minus 4. So what is inside the ln is our function. So here our f of x will equal to 5x minus 4. So you are going to differentiate once. F prime of x will equal to 5. Then I'll come back and now I differentiate. I get my derivative. So it will be ddx of ln of 5x minus 4 will equal to f prime of x, which I have as 5, divided by the original one, which is 5x minus 4. So you end up with the same answer. So you take any approach you feel is easier for you. Okay, so this was our second number. We can try out another one, number 3, and we have ln of root of x minus 3. So still here we shall say that let our y equals to ln of root of x minus 3. Now, what does it mean? It means that when we are differentiating, we shall still say that let our u equals to root of x minus 3. But we know that any number to a power or to a root is the same as power a half. So here is the same as x minus 3 power a half. Now, when you look at this, when we are going to differentiate, we need to differentiate it in a special way, whereby we are going to apply our rule, but hope everyone knows how to differentiate. So we shall have our du dx is equal to, we shall drop the power, which is a half, write the original thing, reduce the power by 1, so which will be a half minus 1. Then after, differentiate what is inside x minus 3, which is a 1. So this will be a half into x minus 3, then power negative a half. And then I'll go back. I'm going to go back now to my thing, and I say I have now y is equal to ln of u. So what am I going to do? I'm going to differentiate my dy du, and it will give me 1 out of u. Then when I go back, I'm going to apply my rule that dy dx will equal to dy du, then times our du dx. So my dy du is equal to 1 out of u times du dx, which is the same as a half into x minus 3, everything power negative a half. But what is u? U is the same as root of x minus 3. So I will say 1 out of root of x minus 3 times 1 out of 2, then times 1 out of x minus 3 power a half. It has been a power negative half, but remember it is from this principle that a power negative b is the same as 1 out of a power b. Then when I reach here, I have x minus 3, x minus 3. Now from your indices, you remember that x minus 3 power half and x minus 3 power half, numbers of the same basis, we add the power. So we have x minus 3, a half plus a half, which will give us x minus 3 power 1, and anything to power 1 is x minus 3. So meaning that in our numerators is 1 out of 2 into x minus 3. And that is our answer for dy dx. Okay, any questions? Okay, how we have obtained this differentiation? Okay, now let me put here side work to help the member for this kind of differentiation. Now, if we have this differentiation as x minus 3 power a half, how do we differentiate it? Now, here, in order for us to differentiate, still we can use the chain rule. So you can say that let x minus 3 equals to w. So I'm going to get my dw dx. So what will I have? I will say my dw dx will equal to 1. And therefore, it means that our u is equal to w power half. So I differentiate. I say du, the w will equal to a half, w power negative a half. So when I go back to use my chain rule, I'll say dy dx is equal to dy sorry, now here it is going to be u. So I will say dy du. I think let me first erase to be very clear. And let me even remove. Since I'm dealing with u and x, I have to use those ones. I'm going to say du dx is going to be du dw, then times dw dx. So my du dw is equal to 1 out of 2 w power negative a half times my dw dx, which is 1. So here I'll end up with a half, my w, which was given as x minus 3, all of it power negative a half. So that is the same thing that we